everyone. Welcome to this new session of Additive Talks. Today we are going to talk about exoskeletons. To be honest, it's quite confusing to say if this section belongs to the healthcare industry or to the industrial industry. We really hope that both professionals from the healthcare industry and also from the industrial industry will be able to find this section really interesting for their specific activity. My name is Katie Sinze, and I will be your host during this session. I really have the honor to moderate a very interesting conversation between Diana and Matthew. And I'm going to give the floor now to Diana so that she can introduce herself as well as the company she represents.
Hi, thank you very much. I'm Diana Hall. I'm the founder and the CEO of Active Armor. We make 3D printed casts and splints and mobilization devices, the only sanitizable, washable, breathable alternative to traditional casting and splinting worldwide.
Thanks, Diana. What about you, Matthew? Tell us more about you and what you do.
Hi, everyone. Thank you for having me on. My name's Dr. Matthew Dickinson. I work at the University of Central Lancashire in the UK. My predominant area of design is in biomechatronics, predominantly focused on purely exoskeleton technology and design.
Good. Thanks. Well, my first question for both of you is quite simple. Right now, there are different types of exoskeletons, and what are they, and what type do you specialize in? I will start with Diana for this one.
So we do immobilization medical devices. So we do mostly fracture care, casting, splinting, and for chronic conditions and patients that need immobilization for special things such as Charcot foot or diabetic foot, and they need offloading, walking boots, things like that. So we provide custom immobilizers.
Okay, good. And Matthew, can you please lay emphasis on the different types of exoskeletons that we can find on the market and the type you specializes in?
Yeah, of course. So I will keep it very short because we could go on forever with it. So you have soft, hard, quasi, you have active, you have passive, and it goes on and on. Really, my predominant area is in passive structures. So passive or with some active elements to it. So this best way to visualize this would be a crutch. When you lean on a crutch, force is relayed through the actual crutch. It doesn't go through your body, so you're passively moving your force across. If you imagine that actually attached to the body, we're relaying that force the same way. It's a passive structure.
Okay, good. Well, Matthew, over the past 8 years, exoskeletons have come and gone, and also, organizations have been trying to really make sense of this emerging technology field. How do you explain that?
So I will keep this short. The truth of it is they're still there. They've always been there. Now, not to go into too much of a long distance of history, but originated in 1962 by GE. The first powered exoskeleton emerged, the Hardyman. Since then, they did appear. The 90s into the noughties, they started to really emerge. The whole world went, wow, they're here. Then some places just forgot they were there. Some places gripped them and developed them and grew them. And I say some places, a lot of the US, there's a lot of development over there. However, in the UK, for example, we didn't capture this as much. It's still there, and I shouldn't bypass people who are already developing this, but the presence is far greater on the US side. It is starting to creep over to Europe more and more. But it's been hit and miss as to where these things really happen. So the companies are there, and there's an awful lot of work that goes into these. And so it gives you a bit of a misunderstanding as to them actually not being there.
Yeah. So maybe, I don't know if it's just a designation on the market that is changing, because, for instance, at the very beginning, Active Armor used to say it manufactures, custom fit exoskeleton support devices. And then this designation eventually changed over time. And now the company refers to its product, as 3D printed splint. Is it for marketing purpose, Diana?
Yeah, absolutely. We know who our customer is, and
Mm-hmm.
we speak to their need for the use and application. So, for example, when I originally started this company, I called it amphibian skin
Well,
because it can go from wet to dry, and it fits you perfectly, and because of the shape and all that kind of thing. And people didn't. A, they couldn't spell it. B, they didn't understand what it was. And so when I got marketing help, they were like, you really need to make sure that the name and the description and everything is specific for the customer and their needs. So when I moved out of engineering and more into medical devices, a
mm-hmm.
lot of things shifted with the way I communicated what the product was, what it was for, the branding, and all of that has been developed over the last 8 years to what it is now, so that people understand that it's clear, it's simple, the point of it, and it doesn't get kind of clouded by what the technology can do, because sometimes the technology is something cool that people want to grasp onto, and other times they're afraid of it, or it seems new and scary, and maybe they're risk averse population. And so you want to make sure that they understand why it's necessary and that it's very simple and clean, so that it doesn't seem very kludgy and difficult to understand.
Yeah. Yeah, I hear what you said. And I have one question. Does that mean that you don't want to lay emphasis on the fact that you're using additive manufacturing?
No, not necessarily, other than if you imagine what the industry has been doing for the last 200 years, they've been taking some sort of plaster or fiberglass material out of a drawer, wetting it, slapping it on you, and then you leave, right? And so that's what they're used to. That's simple, it's cheap, and all of those things. So it's an entire culture change to even change them to a digital process from
Okay.
an analog process, which is what they've done for the course of history. So you have to give them a really good reason
Yeah.
to want to adapt a new technology without making it seem intimidating. And as you know, when you were saying that companies come and go in this space, part of it is the new technology and the difficulties that you have when introducing a new technology into a risk averse and old school market like this. Because if it seems difficult and hard, and you have issues with, the scanning doesn't work out right, or it doesn't fit right, or it's too expensive, or there's too much of a learning curve in the equipment, things like that, people won't do it, and they
Yeah.
won't adopt it. So that's part of that process, is why a lot of companies came in and came out, right? The technology was so early. And even now, I mean, like, taking a couple of hours to fabricate one of these inside the clinic is too long. We would love to have it down to 10 minutes and have it be completely plug and play. You just, just like you see on Star Trek or whatever, there's like a microwave there, and you press it and it goes boop, boop, and it comes out immediately, right? That's where we're trying to get to. It's just not there yet. And so that evolution takes time, and it takes a culture change, and it takes people being willing to adopt it. And especially in medical devices, that takes a little bit of
Yeah.
effort.
Yeah, good. Yeah, you're right. Which brings me to my next question for you, Matthew. What technologies we used before additive manufacturing to manufacture exoskeletons?
The typical process for it was like Diana said, really, of where you would be looking at fiberglasses, you'd be looking at pliable materials. So this could be plating, this could be pipe work, this could be structures where we could actually fit universal joints in between this. If you do go back to some of the early work from General Electric, you'll find some of the very first forms of where they were trying to emulate the actions of what a human could do, and they were looking at trying to track around the body by attaching large structured pipework around them. So it was, for me, still to this day, that's once technology had advanced that little bit more to allow for the things of 3D printing, things like that, it changed everything. It allowed for things to become bespoke, which
Yeah.
makes everything super exciting.
Yeah, thanks. Thanks, Matthew. Quick reminder for the audience. Please feel free to, send your questions in the Q&A chat of your screen. At some point, we are going to, make a pause and try to respond to the questions that you have or any remarks, really. Diana, FDM technologies is often mentioned as the most widely used EM process for the fabrication of exoskeletons. Do you think it's the only? I mean, it's just for cost reasons?
Yeah, so no, I think cost is one of them. Not only cost of the materials, but also cost of the equipment itself. But I think it's the easiest to adapt to a market that's not familiar with 3D printing, right? When you're messing with resins and powders and all that, you get into expensive equipment and you get into a lot more engineering involved. Yeah. And with, FDM, for me, it's about speed as well, right? I mean, you can have a huge printer that prints a batch of 20, but really I want a unique color. I want it quickly. I want it easy so that it's plug and play. And so with FDM, you can just pop a printer right now into a hospital that's never had 3D printing expertise at all. They don't even know CAD, they know nothing. And they can basically load a spool of plastic in just like a paper printer loads ink, and just load it right in and press start, and it goes and it comes up, and it's self-enclosed, so you don't have to worry about particulate inhalation with a HEPA filter, and it comes out in a couple of hours in a custom color in a safe and easy way. That's why, but again, our products are adapted to all the technologies, because as you know, there are more than one. So right, like design services for people to use on any 3D printer with any material they want. And that's the cool thing about for our international partners as well. It's like, you're not shipping product. You're not waiting for that turnaround time and that cost of fabricating. You can fabricate on site with any 3D printer and any material you want. So if you want it to have a little bit of flex to it, print nylon or whatever. So that's the cool thing about 3D printing in that space, is that you can have design services that go worldwide instantly, and it makes it a global product instantly, right? And we're not shipping specific printers all over the world. And Brazil, where we just launched there, it's a 5-time exchange rate. So they're spending 5 times as much to import an equipment as it is to just fabricate it there. So that's why we're like, okay, this is great, because you can use locally sourced printers and materials. And our hospitals, we already have over 400 hospitals in the United States already have 3D printing labs and innovation centers that are already 3D printing medical models for other things. So we're just saying, hey, now this is a billable product that you can now expand into orthopedics and fracture care with no upfront cost. You already have the equipment, you already have the materials. We're just going to send you design services. Boom, you're making money.
But did you try did you try other AM processes but from FDM?
Oh yeah. I have a whole lab of really cool printers, right? And I use them for different things, so it's not just about fabricating this one type of product, but the evolution has been 8 years. So you can imagine that as a chemical engineer too, I'm a total geek, and I love nerding out on new technologies, trying new printers, trying all of the new processes. It's like, ooh, look at this scanner. I remember when we first got the iPhone scan, man, that was so fun, right? Because now everyone has a 3D digital scanner in their pocket, and you can just scan anything that you want. It's so fun. And that makes it so much cheaper, more affordable for everyone, and easier for people to use, and more comfortable with it, with the technology. Have it right on your phone, right? So we try all of and we advance with that tech. So if there's a new 3D printer that really will knock something out in the type of material that's biocompatible with this mechanical properties that we want in 2 minutes, I'm going to it. I mean, so just so you know, like whichever one of you develops that, call me, because I'll pay for it. That's all I'm saying.
Okay, good. Matthew, last year you worked with a student who wanted to come up with an idea to provide support and give extra strength to her cousin's back muscles and spine. what type of parts, can, or I mean, should be 3D printed when the entire device is not entirely manufactured via AM?
Yeah, I mean, to give you an overview of what that was about,
Yeah,
that actually turned out to be even longer than a couple of years. It's been
really.
about 4 years since.
Oh.
So what this came about from was a young woman at the age of 14. She was interested in trying to offer a method of support to a younger cousin who has a disease known as ALS.
Mm-hmm.
And personally, I'd never heard of it, but once I'd learned about what this was, it was a way to
Mm-hmm.
actually offer some level of. She was basically describing what she talked about. She was describing an exo. She was just saying, why is there not any special type of shirt that children can wear that can help
Mm-hmm.
them move? And this got me on the huge journey of crazy ideas of looking at 3D printing. So we started off and looking at the actual supporting of the body. We started looking at spinal structures, started
Mm-hmm.
looking at a continuum method where you could block pieces together and you could actually you could look at a skeletal structure that would in essence kind of grow with children. So a massive thing about this was, could we design an exo that was affordable?
Mm-hmm.
Could we design an exo that was accessible? And the reason that we've done this is not to get too boring, but there was some research which published which looked at the idea of that children can often feel completely dislodged if you present something to them and then you take it away. And you kind of
Yeah,
go, the thing is with any types of devices, when
yeah.
we're asking people to embrace them, they need to feel like it's an extension of them. And what we wanted to do was to introduce an exo that would grow with them. This
Oh.
was the idea of having spinal segments. As the child grew, you can add spinal segments to it. So we'd looked at carbon fibers, we'd looked at aluminiums, and it was like, this is not an affordable option. So then, sulking in my office, I looked at my Ultimaker and looked at the PLA and then kind of thought, you know what? What if I test the PLA? So I tested it in all crazy states. In fact, this is an old test piece. This is one of the old test pieces that we had.
Oh, yeah.
And we're looking at head support, we're looking at a position, we're looking at how well that the body would do it, and it was doing a crazy good job.
Yeah.
So what we in essence done by approaching it from that perspective, early doors from that perspective, was we'd come up with a way to introduce one exactly like Diana was just saying, of where it's all right people having the kit and but being able to literally ship ideas across. So you could email these pieces to
Yeah.
families, and because desktop printers are so accessible,
Mm-hmm.
it would give them a way to offer some maintenance for it. So what we'd done with this particular design is we'd looked at trying to keep it as simple as possible. So this was basically six pieces all bolted together, and we'd been able to cut down the cost by a factor of 10. So yeah, it's when it came to it, the parts that we were using, we started on that particular one, but then from there we've moved a little bit forwards, and yeah, as ever, as you can imagine, there's always fine tuning. Some of the lifespans that we tested were a little bit short, and we just now look to making them a little bit more longer in their lifespan, I should say.
Yeah. Wow. Cool. And now what's happening? I mean, are you going to work with this student again? Yes.
So since then, Christina, she applied to be a triage nurse, and she's now been given a full scholarship, and she's now working in the UK in the
Mhm.
NHS as a rehabilitation nurse.
Oh,
And so she's less of a student now and more of a woman. And yeah, so her story, she still gets in touch and she still comes into the lab, and we
yeah.
still look at further applications with it. Since then, though, we've also been looking at the idea of looking at people in the workplace,
Okay,
trying
good.
to minimize loading around the workplace. So
Good.
it's, if you will, it's grown from this small, simple idea. It's grown into this bigger element, which is super exciting. I won't rabbit on much longer.
No problem. Anyway, keep us posted. Um, I can see that. Oh, one person in the audience is raising their hand. Mapas, if you hear me, please try to write your question or remark in the Q&A chat, because for some reason I can just give you the floor on this conversation. So please feel free to write whatever you have to say to Diana or Matthew in the Q&A chat, and we'll read it. Well, good. Moving forward, Matthew, are you going to use to explore other technologies other than FDM, in the specific field of activity? And what's the challenge with materials? Because you said it's one of your hottest topic you often come across in ASTM.
So, materials is a huge area. And the thing is, when you refer to the material aspect,
Yeah.
3D printing is insanely good for its unilateral loading. When you actually introduce, especially FDM, when you introduce
Yeah.
shearing, that shearing element can be can be problematic. And
Mm-hmm.
one thing that we are still very passionate about doing, because now we don't just have one widget in the lab, we have quite a few different widgets all over the place. But
Yeah.
one thing that we're very, very keen to be able to do is still have 3D printed elements, but be able to look at reinforcement around them key points. So I
Mm-hmm.
use this for example. This is a knee brace piece which is
Okay.
connected to a lower limb.
Yeah.
So by itself, because the human body does nothing in a straight line, it's
Mm-hmm.
always a curve. Loading the body and loading this piece, we get shearing around this particular point. So we're
Yeah.
looking at carbon fiber tubing to just look at them processes. So there's so much challenge when it comes to materials, because materials are great and everybody can get access to them.
Yeah.
But just like Diana, we just need to think about how we can apply these, how apply these safely. And that's where the ASTM element from my side comes in. Thinking about how we test them, not for just the materials, but also how the human is doing whilst wearing this equipment. So it's such a large field for that area.
Yeah. Do you want to add something?
Yeah, I was going to say yes, and both testing for mechanically how they're doing with it, but also chemically how they're doing with it. That biocompatibility is a very important factor, not to mention the finish. You want to make sure that there's no microporosity during the additive manufacturing process,
Yeah.
because, and I'm talking about, so small you can't see, you're looking with a microscope, or is there any brittleness, is it cracking on the exterior, anything that can trap moisture and bacteria against the skin is a problem. And the strength of the manufactured product in FDM is all about that layer cohesion, right? It's not about the material itself. The material itself, the strength of it doesn't matter. All that matters is how strong the layers are in FDM, for example. And that's why we do look at other technologies that use resins, for example, that
Yeah.
have UV light that cure them all into one piece. Now you're talking about having injection molded strength in
Yeah.
an additive manufactured product. But then you have to look at the materials that you can use in resins. I mean, like, for example, this product right here is ABS, right? And you can't do that. You have with resin, right? Yet.
Mhm.
And so this material, we like it because of the finishing properties. It's very easy to solvent smooth the surface of a product that's ABS, or like, and how Dr. Dickinson is working with PLA, and
Yeah.
there are positives and negatives to that. I mean, it's brittle, but you can inhale it while you're heating it and those kind of things. So you want to be very careful about not only what it's doing to the patient, but also what it's doing to the manufacturer.
Yeah. Right.
Like, what are the materials that you're using? Is there off gassing? Are there particulates coming out of it? And then on the user interface, is it smooth and comfortable to the skin? Does it trap moisture and bacteria? Is it biocompatible? And then on the third level, is it recyclable? Is it good for the planet? Or is it biodegradable? Can it break down? I mean, we can make these out of hemp, we can
Yeah. Right.
make them out of coffee beans, so, and then the real question though is, what does that do to our human bodies, and how do we interact with it? So not only mechanically and physically, like how strong is it, and how does it, how much torque can you put it on, things like that, but also chemically. And so there are so many different layers to think about. How do we make it? How do we source it? Where does it come from? How does it react to the manufacturers? How does it interact with the customers and the consumers? And then how does it recycle back into the system, making sure that we are cognizant and thinking about all of those steps and careful about it, so that we don't scale up with, we want to make sure that the processes that we introduce are scalable, and that is affected by the technology and the way that you fabricate it, as well as the materials. And so all of that's very important.
Yeah, you mentioned something that really resonates within my heart. How does it react, with the human body? And I was like, what type of side effects we can have if an exoskeleton has not been well manufactured?
Mm-hmm. Yeah, and the quality control, because exoskeletons by nature have to be custom pretty much. I mean, it's or custom fittable at the least, right? There's a lot of manufacturing issues that come into play, because you can't just have a bunch of inventory. You're basically printing on demand, and patient specific, meaning that there's not like a widget where you can quality control one and then just mass produce 1 million of them for pennies, and that's part of the value of this, just as manufacturing alone here in the US. We can't compete financially with mass manufacturing millions of widgets like they do in China, and then shipping. We're not trying to, but here we have direct access to the American consumer, and so if we can fabricate on site, mass customization is the future of manufacturing in the United States. That just is what it is. And so the more we figure out how that process can be quality control proven, and that's why it took me 8 years to have point of care fabrication, right? We always fabricated at a centralized location so that we could manage the quality control process before it gets shipped out to the patient. Now, and to the hospital or clinic. Now we have it where it can be done at point of care, because we have standardized so much of the customization. And I know that sounds like it sounds like an anomaly, but like to say that you can do both, right? But as much of the customization as you can standardize, the more control you have over quality of the process, of the product through the process. And one of the cool things I was going to mention about the materials that I didn't mention earlier is that the actual additive manufacturing process can change the chemical structure of the material, the raw material. So even with FDM, all you're doing is melting plastic from one shape into another, and you're actually changing the chemical properties of it. So through the FDA and some of the research abstracts and things that we've done, we've actually done an analysis of the chemical composition of the plastics pre and post processed, and how does that change with the different FDM processes, or with the different SLA and all the other multi-jet fusion printers and all of that. How do the chemical properties change, and what does that do during the manufacturing process? So that whole thing, I'm kind of going off, sorry, on a tangent, but I do that. My mind goes a little bit circular, so I apologize for that. But yes, to answer your question, it is important definitely to think about during the manufacturing process, how are you doing it and why, and what does that mean to the end product, strength, chemically, all of those things.
Thanks, Diana. And I so much you was nodding when you were talking. It was that's right. That's
couldn't
right.
say it better, Yeah, absolutely.
His mind was going rogue with mine. I appreciate that.
You're right. Do you want to add something to what she said?
There is not much you could really bolt to make that any better, really. Yeah, no, I said it perfectly in my eyes. Absolutely.
Okay, good. Well, we have one question for you in the Q&A chat, Matthew. When looking at standards, where will it be easier to apply additive manufacturing, industrial exoskeletons or healthcare exoskeletons? I think, I mean, the question can be answered by both of you, actually.
Absolutely.
Yeah,
I'll go on the industrial side. It's funny from that question, because we were literally in a very similar discussion to this not 2 weeks ago.
yeah.
From our experience on the medical side, medical side has a whole extra level of complications to be considered.
Oh,
For us, it can be. I hate to say easier, because that makes it sound like there's a back door, because there really
don't
isn't.
use that word. Don't use that
Yeah,
word.
there really isn't. The industry example is a little bit easier, just because of you're not down the medical technology route.
Mm-hmm.
But what you're actually doing with that, you're looking at preventative technologies rather than a rehabilitative technology. And
Yeah,
I think, from my experience of seeing standards go through discussed more, I've seen more industrial ones talked about. But I
mm-hmm.
think that's probably because the groups that I sit in tend to be of an industrial approach. So
Yeah,
this could be your construction site through to military application, for example. So these tend to be that types of areas. So whether my answer is the best, not sure, but my experience would be industrial can be a little bit easier to take the first steps. But I'm sure, Diana, you'll be able to answer that one better than I for the medical side.
Yeah, no, definitely. What we were talking about earlier about that interaction with the human body, especially for implantables, right? You're
yeah,
talking about it becoming a part of you. I mean, not just wearing it, but it being implanted inside you. And the regulatory environment for medical devices is it's there to protect us, but it also holds us back from being able to introduce new innovative products into the market. And unfortunately, and I'm going to put my aluminum foil hat on right now, so bear with me, but um, think about who funds the regulatory agencies as well, right? It's going to be big pharma. And so the larger companies aren't in bed with the regulatory folks. And so it becomes, they use it as a competitive advantage
yeah,
to keep people out of the market, or, introduce their own products in. So I don't want to like go rogue on that, but I'm just saying that like, introducing it into the medical device space in the US and then in other countries, it's also because of the healthcare system, right? Because in Canada and, places where they have, a federal healthcare system or a government healthcare system or whatever,
yeah,
it's different because of insurance requirements and reimbursements and things like that. So
yeah,
there's a lot to think about in the medical device space.
yeah.
Both in the US and outside in the other countries. And so that's one thing in healthcare that you don't necessarily have in the other industries.
Yeah, it makes sense. And then before we actually respond to Yuan's question, because he kind of, I mean, his question is a way of summarizing everything that has been said during this conversation. Matthew, I wanted to know if you have a different perspective, first on the, on the way we should measure the performance of 3D printed devices at the research level, because I guess the process is quite different when we talk about something that's going to be commercialized and something that's done just for research purpose.
Yeah. I mean, there's a lot of overlap with what Diana's been saying. For example,
Yeah.
one thing that we'd noticed very, very early state is it's okay to use 3D printed materials, but when you come to cleaning, when
Hmm.
you come to sanitizing, the side effect of not being able to sanitize, the process for the bacteria embedding itself into the surfaces makes
Yeah.
it incredibly difficult to clean. And moving forwards, when considering these types of things, it's all about that aspect. It's all about considering them key aspects when you're referring to that type of safety side of it.
Yeah.
So moving forwards with that, I think that's they're the key bits, I would say.
Yeah. Okay, good. And Diana, does Active Armor have plans for future applications?
Yep, we already do a bunch of veterinary applications, and we've really gotten into body armor lately, and custom fitted sport protective gear. But it's really an unlimited number of industries that you could go into with exoskeletons, right? As long as you're dealing with the human or animal body, it's not one size fits all. And so you're always going to have a need for exoskeletons no matter what. And I just wanted to go back to what Matthew was saying about the material properties or whatever, but one of the main ways that we've always sterilized things is with heat. And so then when you get into thermoplastics, you're adding a whole another level of, is it going to deform? Is it going to catch on fire? Is it going to, melt? Whatever is going to happen. And so that's another thing, is about sterilization practices and cleaning, just like you said. And that's why microporosity is important, that people don't even think about. And that's why medical devices in the industry, it's so important in that space. It's not, people think, oh, it's just about the mechanical properties, but it's not. And the mechanical properties with something like this, well, I chose to make this thin, breathable, lightweight. Does that mean that it's less, that it's going to immobilize me less? Or do I have somebody, a doctor in fracture care, who, yeah, you could use a thin, lightweight spider webby thing, but no doctor is going to prescribe that for fracture care because it's not protective enough, because they want it to look like a club on your arm, like an airbag on your body, right? So sometimes it's not just about the application of whether or not it immobilizes. Sometimes it's about protection and other things like that. And so you have to kind of bring all of that into, well, we can make something really strong and thin, but is that what the customer wants? I mean, you also have to think about not just what the technology can do, but who your customer is. And it's not the guy walking around with a fracture, right? The customer is the provider that's writing the script for it or prescribing it for a certain injury or condition. And they're the ones who you need to make sure that the product matches and fits for.
Good, interesting. Matthew, do you have any questions for Diana, or vice versa?
Oh, wow. Yeah, there'll be millions. There probably will be, actually. When you come offline and you go, you know what? I have millions of questions.
Yeah.
Should
yeah.
go.
Yeah, it caught me off guard there. I can't think of the
That's
moment.
fine. I'll ask a question first. I have a million also, but mine are like this, man. Because I talk a lot. What can I say? No, but I do have a lot of questions, and one of them is, who wants to help us work with us? I mean, we're providing design services that have been tested for 8 years on thousands of patients and by the top orthopedic surgeons in the country, in the Olympics, in the NFL, professional athletes, etc. And we are just looking for an opportunity to expand worldwide. So if you guys know of any way that you can help us get into these other countries and into their regulatory approval process and everything, by all means, please help us. I mean, we really want this to be successful. We don't want this to be a flash in the pan, it came and went kind of a deal. We want this to become the standard of care, not to build up the company, but because the mission for us is to give people their lifestyles back while they're immobilized. We're talking about, tens of millions of people needing immobilizers, even in locations where they have substandard living conditions and they can't sanitize their hands or wash their hands anyway. And now you're adding a whole nother level of kind of lifestyle freedom where you can swim, bathe, shower, just practice basic hygiene. And that's really what our mission is, to improve the quality of life for people that need immobilizing for whatever reason, fracture care, acute injuries, chronic conditions, whatever. So if people buy into making this the standard of care, then I think we can do that. We can reduce our infection rates. We can reduce complication rates. We can improve the quality of care for patients and their lifestyles. So anyway, I could go on forever, but yeah, I mean, feel free to hit me with any questions too. And you can find me. I just found you, Dr. Dickinson, on LinkedIn, and I sent a message to him, and I was hoping that we could connect before this, but I'm sure we will after.
We
but
will definitely afterwards.
Yeah, you can
100%.
find me. I mean, I'm on all of the platforms, so please reach out to me.
Yeah, 100%. Because one thing that's completely apparent is Diana, like a lot of people from the industry side of things, there's so much going on, and there's so much idea of this type of things can change people's worlds. It can makes people walk again. It can make people live good, productive lives again. It's insane the levels of possibilities that are actually out there. So my perspective is extremely exciting from that side. So yeah, I'm very, very keen to reach out. The only thing I think I would add from these sides is when some of the bigger things when we consider standards from the industry, because I was just thinking one of the former questions, one of the biggest
Yeah,
standards about industry
correct.
that we really come across is defining an exoskeleton. When somebody says, "What is an exoskeleton?"
Thank
we
you. We
we
should have
have
started the panel with this.
crazy amounts of different directions. So we have soft exoskeletons, we have hard exoskeletons, and at the moment, the categorizing, the understanding, the education, when it comes down to it, for me, my experience of what I've seen, it is just education. When people see the potential of what this type of technology, like what Active Armor are doing, how that's going to change the people's lives, it's a no-brainer, as they say.
Oh, good. And you just, I mean, give one part, yeah, you partially respond to Yuan's questions because he was asking the current limitations, in the use of additive manufacturing technologies in the production of exoskeleton applications. And I'm glad that you just say that really the first limitation is that people do not really know what an exoskeleton is. But regarding additive manufacturing, what do you have to say? And
So
what's your point of view on the evolution of this market?
the evolution of it, I think it's quite nice because in the entire conversation that we've had, we've just thrown out pieces about resins. We have powder methodologies. We have
Correct.
so many different options that are emerging. But I do firmly believe to keep cost down is our main focus because the biggest thing of it is. Uh, if I mean I'm when I was little, some of the TV shows you'd see is I want my flying car. Where's my flying car? So the point is if we're not developing technology that isn't affordable, no one's going to use it. If no one's going to use it, it's never going to evolve. So we need to great think about this technology and how it's going to change things, but also think about the bigger implication of what we're doing, and then I think then we can actually look to be able to be in a position of being able to spread it that little bit further.
Yeah.
Good.
And to wrap it all the way back around to your original question on why did
Yeah.
I change my marketing message? That's exactly it. It's also about making it simple because if it's confusing, I mean, if you have to, if it looks like you're going into a fighter jet cockpit to try to, manufacture something on site, that's why Active Armor has worked so hard to make it scalable at point of care, because that makes it so much easier if providers can use it, and they're not engineers, they're medically trained. Some of them don't even know how to use their smartphone. So it's a matter of how do you make it so easy and turnkey for the public to understand but also to use, as well as affordable. That's what allows for adoption, and that's what allows for adoption on a grand scale, to make it a standard of care,
You're
crossing
correct.
that chasm from the innovators and the forward thinkers and the novelty into this is how we do things now. Like we've
Yeah.
evolved. And that evolutionary process is why when you said, why do they come and go? That's why we haven't evolved. We've tried it, and we're starting to adapt it more and more into our lifestyles as this is how we do things now. And that's that leap that we're trying to make to incorporate it into our day-to-day lives.
Yeah.
That's right. Yeah.
Well, good.
Yeah.
Do you want to add something, what you?
Yeah, I think I think that's a great point. Just I can't stop with this. That's a great point. And I think the only thing that I found with looking at some of the exos we have for the lower limb,
Yeah.
it's just about the loading. So we've been taking a combination of printing and hardened structures,
Yeah.
combining the two together, and keeping that cost down, but keeping it simple to manufacture and maintain.
Yeah. Right.
And
Good.
yeah, that's all I'll add.
No
I
problem.
totally agree. And the materials are part of it, the process is a part of it, and the cost is all a part of it on how do we make these stronger, more mechanically sound. Because, ABS is used to make a hard hat if you injection mold it, right?
Mhm.
But then all of a sudden you 3D print it and you've lost 80% of the strength right there.
Yeah.
by the layering and all that kind of stuff. So it's not so much about, it is about the material, but it's also about the manufacturing process, and that is something that we're still all learning and evolving. And I've changed a million times, and I'll change a million more, as we find out new ways to do things and new materials to use and new technologies. I mean, curing resin with UV light in a three-dimensional space, and then it just like boom and it pops out. That's awesome, right? That's totally cool. Now how do we make it easy and cheap? That's the other, that's the next question. And
Yeah.
and more robust in what we can do with it. So um that's that's the really fun part of this job, right? It's, as things, they're always changing. It's not like, you go to the steel mill like my grandpa did, and go every single day and do the same job, heat the iron and do all that kind of stuff. But like to be able to have new technologies in 3D digital imaging and in manufacturing and new material science and all that kind of stuff every single day, it's awesome. It's great. I love to get up in the morning and say, oh my gosh, what's going to happen today, you know?
Yeah, right. That's right. I mean, I feel the same with the way we actually cover this technology. So yeah. Um, yeah. Well, on these good notes, I can't thank you enough for being here on this conversation. I'm really glad that 3D Adapt Media has been able, to put together two passionate experts on this topic, and I really hope that moving forward we'll be able to sit down together again and try to discuss the advancements on this topic and what really needs to be done again to push the application up forward. I also thank the audience. Thank you for your interest in this panel. Thank you for your questions. And for those who didn't have the opportunity to join, please note that we'll have a recording of this panel online very soon, probably next week on our online media, and sent to the newsletter so that both people from the healthcare industry and also the industrial side of the business, can benefit from it. And we do have one question from somebody for the audience before. So before we leave the virtual session, I would really like us to respond to this question from Misra. What do you guys think of adding 4D printing in exoskeleton technology? That's quite interesting.
Yeah. I personally, I love it. I think it's awesome. I mean, like one that I was looking at was arterial stents, right? So you 3D print a arterial stent in a tiny, like specifically body specific, but then you're able to insert it into an artery and then have it when it interacts with the blood flow, when they release the blood flow and it interacts with it, it's allowed to expand and fit specifically inside that artery. Or as Dr. Dickinson was saying, it grows with you, right? As you grow up, it grows with you, which is so great in spinal applications for, infants with spinal deformities, because they're growing all of the time, and you can't just put something
Right.
on and then 3 weeks later they've outgrown it, like our kids with their shoes or whatever. I mean, it needs to be able to fit to you and grow to you and move with you and all of those things, unless you're trying to immobilize them, and then don't move with you. But you know what I'm saying? Like that's definitely important, is that fourth dimension. And so time, expansion, growth, all of those things. Definitely. And the more dimensions we can add at any time, the better it is for humans, because we're not two-dimensional, And so when we add 3D printing and 3D exoskeletons and things like that, we're getting 3, and then you need 4-dimensional because we have time, we have growth, we have all those things. So let's keep going that path. I definitely think that's the future.
Yeah, good. Dr. Matthew Dickinson, you want to add
Yeah.
something?
No, it's Dana raised some incredibly good points there. Of that when you're actually wearing an exo, be it in a medical application, be it in a work application, or be it in just social. So you got to think of it. We now have electric bicycles.
Yeah.
It's not too far of a stretch to imagine that we are going to start to see recreational exos in the future. So to introduce the element of a 4D piece for it to be able to maintain itself, recover in some ways, the device can keep itself maintained. It's exciting, super exciting.
Well, and let's don't even start talking about AI, but I have to bring it
That's
in
a
here.
different topic, Diana. People do not agree with
I'm just saying that when your exo can learn, that's another fourth dimension, is it can grow and change with you, with your changes in your environment or your activity or whatever. Mm-hmm. And now we're talking about a whole nother level of additive manufacturing in combination with machine learning. And that's a whole nother topic I would love to get into sometime. But yeah, anyway. Yeah, that's another fourth dimension. That's
100%. Yes, totally agreed.
Well, I hope this responds to your questions and that he helps you or Misra. Well, if you have no questions from the audience left, I think this is it. This is the conversation about the use of AM for exoskeleton applications. Please, Diana and Matthew, please keep us posted about what you do, and if we can share with the audience. I'm sure they will also be, looking forward to hearing your news and and where you're heading. So thanks again for joining us, and let's stay in touch for the next conversation. Stay tuned and stay safe wherever you are in the world. Bye.
Thanks, everyone.